Well, hey everybody, Mr. Reeves here, and we have moved on to IXL skill Z14, comparing linear functions, tables, graphs, and equations. Remember when we're looking at proportional and non-proportional linear relationships, there's four ways we can represent them. We can represent them by words, by tables, by equations, and by graphs. So we're going to be looking at comparing three of those, tables, graphs, and equations, and seeing if we can pull the same information out of the different forms and then compare in terms of greater than or lesser than. All right, so we've got function A and function B. Function A is an equation written in the form y equals mx plus b. Remember, when we have an equation, we have a non-proportional linear equation. It's y equals mx plus b, where m is the slope and b is the y-intercept. And remember, slope is change in y over change in x, and the y-intercept is the y value when x is equal to 0. So the y value when x is equal to 0. So if they want us to compare the slopes, well, the slope on this one is 3. All right, very easy to get the slope from an equation in slope-intercept form. From a table, we're going to have to find the change in y over the change in x. Well, if I go from negative 18 to 4, that is an increase of 22, right? And if I go from 4 to 16, that is an increase of 12. Well, those didn't change by the same amount, but if we look over here, neither did these. So negative 9 to 2, that's an increase in 11. And 2 to 8, that's an increase in 6. So if you look, we have 22 over 11 and 12 over 6. So even though they look different, they both simplify to 2 over 1, or simply 2. So the slope for our table is 2. So the slope for our table is 2. The slope for our equation was 3. So which one has a greater slope? That would be the first function. Function A has the greater slope. All right, and we are wonderful. Okay, this time, instead of giving us an equation and a table, they gave us a table and a graph. And once again, they're asking us to compare the slopes. So again, slope in a table is going to be change in y over change in x. So if we take a look here at our change in y, negative 6 to 12, that goes up 18, right? And 20 to 12, that one goes up 8. From negative 5 to 4, that one goes up 9, I believe, right? And from 4 to 8, that one goes up 4. So if we look at our change in y over change in x, we had 18 over 9, and we had 8 over 4. Again, at first glance, they look different, but 18 over 9 and 8 over 4 both simplify to 2 over 1, or 2. So the slope of our table is 2. Now if we take a look at the graph, we're also doing change in y over change in x, but we do it on the graph. First of all, this is a positive slope because it goes up from left to right. Remember, when you want to find the slope of a line, you could pick any 2 points you want to, but you're looking for a point that's on the line and on the grid. And sometimes it could be a little tricky. I'm thinking that point right there looks like it, and as I follow this line up, it looks to be that point right there. So it sure looks like it goes up 1, 2, 3, 4, 5, and over 1. So it looks like it goes up 5 and then to the right 1. And a great thing to do is check it again. All right, so if I do it again, if I go up 1, 2, 3, 4, 5, and over 1, it sure appears that's correct. So the slope for the graph is 5. The slope for the table was 2. So what does that mean? That means that A is less than B. A is less than B because 2 is less than 5. Okay, now they've given us a graph and an equation, right? So again, the equation, finding the slope, is not bad at all. We just look at it. The slope for the equation is 3. The slope for the graph, again, is going to be the change in y over change in x. Again, find points that are on the line and on the grid. So I think that one, and what do you think? That one right there, up 1, 2, 3, 4, 5, and over 1. 1, 2, 3, 4, 5. Wait. 1, 2, 3, 4, 5, and over 1. There we go. All right, and if I went down 1, 2, 3, 4, 5, and back 1, I'd also be there. All right, so again, the slope of this one is 5. The slope of this one is 3. 5 is greater than 3, so A has a greater slope than B. All right, so we did a table and equation. We did a table and a graph, and now we've done a graph and an equation. So we did all 3 different parts with slope. And now look at, now they're asking us actually to compare the y-intercepts instead. Well, again, in an equation, the y-intercept is simply that second number. Remember, we have y equals mx plus b. M, what we were just looking at, is the slope. Of course, that's our change in y over change in x. And b, that is our y-intercept. And again, that's where the value of x is equal to 0. That's where the line will cross the y-axis, okay? So our y-intercept is 3 for the second one. Now, if we take a look at the table, we would want 0 to be in this table. So the problem is, unfortunately, 0 is not in the table. So we're going to have to find it another way. All right, well, let's take a look and see if we can figure out what the slope of this table is. All right, from negative 8 to 6, that looks like that went up 14. And from negative 6 to 1, that went up 7, right? From 6 to 20, that went up 14, and that went up 7. So our slope is 14 over 7, or 2 over 1. All right, so what does that mean? That means our change in y over our change in x is 2 over 1. How is that going to help us? Because if we go to this table, all right, I'm going to rewrite this table over here where there's space, right? So we've got this, okay, we've got x and we've got y. We've got 8 and 20. We've got 1 and 6. I'm going to put a 0 right here because that's what we want x to be. So remember, our from there to there was 14, and from there to there was 7, right? Our change in y over our change in x was 14 over 7, but that's 2 over 1, right? So if this went over 1, this one should be up 2. Does that make sense? So what should this value be right here? This value should be 4. 4 plus 2 is 6. 0 plus 1, that would give us what we need. And that will give us our y-intercept. So our y-intercept here is 4. And by the way, we can check that, right? 1 times 2 is 2, plus 4 is 6. 8 times 2 is 16, plus 4 is 20. That equation, y equals 2x plus, what did we say the y-intercept was? 4. That is the correct equation for this table. Hopefully you had a chance to watch my video on Z12. If you did not, go back and watch it, because that's probably the most challenging thing that we're doing, is finding the equation from the table when it's not just a straight multiple or sum. All right, so the y-intercept on A was 4. The y-intercept on B was 3. So A has the greater y-intercept. Okay, what about this one? So that one's back to looking at the slopes. I'm going to skip over that one. All right, what do we have here? Okay, now we've got a different idea here. The y values, we want to know how the y values compare given the x values. Okay, so remember, when we have a table of values, okay, we have x and we have y. X we usually refer to as our input, and y we usually refer to as our output, right? So x would be my input here, and y would be my output. So it's saying the y value when x is -1. So I'm going to go y equals 4, but instead of x, I'm going to put -1 here. So what do I get? I get 4 times -1 plus 3. So I get -4 plus 3, and I get -1. So y is equal to -1. So if I were to make a table for this first equation, if I put -1 on it, the y value, the y value would also be -1. Threw me off for a minute. When x is -1, then y is also -1. So the question then is, if I made a table for this next one, and I put -1, what would be for y? All right, well, the great thing about the graph is you could just look at it. So do you see right here between 0 and -2 is -1. So I'm going to go down to my line here, and it sure looks like when x is -1, y is -7. All right? So on the graph, -1 goes with -7. That was much easier to find than it was from the table. Do you see how, given different forms of the linear relationship, finding information can be easier or harder depending on the form? That's why we have different forms. It's amazing. Okay, so what do we know then? Do you agree that -1 is greater than -7? All right, so that means that the y value of function A is greater than the y value of function B when we input -1. What just happened there? That was weird. All right, so again, we're back to slope. I'm going to let you guys take a look at slope. What do we have next? All right, again, slope. Same idea with slope. Comparing slopes, I think we're pretty proficient at that. Okay, well, now they want us to compare slope, and they want us to compare y-intercept. Okay, so remember, I know I've said it over and over again. I'm going to keep saying it over and over again. Y equals mx plus b. M is the slope, which is our change in y over our change in x. B is our y-intercept, which is the point where the line crosses the y-axis. It's also the y value when x is equal to 0. All right, so if we take a look at this first equation, y equals 2/3 x, do you agree I could write it as y equals 2/3 x plus 0? I sure hope you agree, because that is the case. So my y-intercept is 0, okay? And my slope is, let me use a different color. My slope is 2/3, all right? So m is 2/3 and b is 0 for my first function. Okay, now again, slope is change in y over change in x. So if we do this, that's plus 3. That one is plus what? 9. That one is plus 2. That one is plus 6. So if I do my change in y over my change in x, I get 3 over 2 or 9 over 6, but both of those simplify to 3 over 2. So my slope for function b is 2/3. But what about my y-intercept? Now again, y-intercept is when x is 0, and we would hope that's on our table, but it's not on our table. But let's see if we can make a table where it's on there. So 10, 4, 2, 0. All right. And you're going, well, how can you just put it there if it's not there? Because this represents a linear function, which means constant rate of change, right? So 10 was 13, and 4 was 4, and 2 was 1. Remember, the change in y over the change in x is 3 over 2, right? In fact, let me take off 10 and 13, and I'm going to put 6 here, because that would be plus 2, and then this would be plus 3, and this would be 7. See how that works? And if I did 8, another plus 2, then I would do 3, and this would be 10. So that's all we're doing, is we're putting points on the table that would be on the line when we graph this. 0 plus 2 is 2. Well, what do you add to 3 and get 1? Or if we subtracted 3, what would we be at? We'd be at negative 2, right? Do you see that? Negative 2 plus 3 is 1. So that's what our y-intercept is. There is our y-intercept. This was our slope, all right? So our y-intercept is negative 2. And again, if you want to check it, it's a great thing to do, all right? If I did 2/3 of 10, right? And then, I'm sorry, it's not 2/3, Mr. Reeves. This is why we check our work. The slope is 3/2. Y over x. I'm like, that doesn't work. See? 3 times 10 is 30. All right, divided by 2 is 15, and 15 minus 2 would be 13, right? 3 times 4 is 12. 12 divided by 2 would be 6, and 6 minus 2 is 4. 3 times 2 is 6. 6 divided by 2 is 3, and 3 minus 2 is 1. So it works, all right? So the slope of function A is equal? No, they're reciprocals. The slope of function A is greater? No, it's less than. The y-intercept of function A is equal? No. The y-intercept of function A is greater? Yes, right? Negative 2 is less than 0, or 0 is greater than negative 2. So it's that last one that we are looking for, okay? All right, I'm going to do one more, and then we're going to call it a day on this. All right, so now they want us to compare the y-intercepts, and they want us to compare y values given x. Well, guess what? I'm glad they didn't give us a table, because the y-intercept is right there. B equals negative 2. And right here, what do we have? We have b equals negative 1. So we've got the y-intercepts to compare. We can see that the y-intercept of function A is less than the y-intercept of function B. Now they want to know, what is the y value when x is 2? All right, so if I were to make a table for function A and I were to put 2 in for x, what would y be? Or if I were to make a table for function B and I were to put 2 in for x, what would y be? Well, graphs are awesome, because you just go over to 2 and then you go up until you hit the graph, or sometimes you have to go down. So do you see that point right there? That point when x is 2, y is 7. So 2, 7. Y is 7 when x is 2. Now this one, I'm going to put 2 into the equation. So y equals 5/2 times 2. I'm going to go ahead and put 2 over 1 because we're multiplying by a fraction, right? And I could either go 5 times 2 is 10. 10 divided by 2 is 5. Or if I wanted to, I could divide 2 by 2 there. Either way, I get y is 5 minus 1, or y is equal to 4. So when x is 2, y is 4. So how do they compare? Okay, so the y value is greater. Okay, so if we go back to the y-intercept, all right, for function A, the y-intercept was less. So the y-intercept of function A is less. That is true. All right, the y-intercept of function A, well, if it's less, it can't be equal. The y value of function A when x is 2 is less. No, this was 7, this was 4. The y value of function A is greater. Yes, right? The y value of function A was 7 when x was 2. Here it was 4. So it's actually the first one and the last one that are true. What did I do wrong? The y-intercept of function A was 2, and the y-intercept, oh my goodness. What did I have 2. Look at that, ladies and gentlemen, boys and girls. I wrote -2. It's +2. Well, there you go. Sloppy, sloppy, sloppy. I wrote it in the correct spot, but for some reason I put a negative on there and I just didn't catch it. Alrighty, well, I don't want to end on a negative note. Oh, what? Do we do the same thing? Okay, I cannot end getting a question wrong. I refuse to end getting a question wrong. So what are they asking us to compare here? They're asking us to compare slopes and output values. Okay, here we go. Real quickly, so what's the slope on this one, guys? Slope on this one is 1/2. What's the slope on this one? Slope on this one, it goes up. Let's see here. Up 1, 2, and over 1, 2, 3, 4, 5. So the slope on this one is 2/5. Okay? Slope on this one is 2/5. So do you guys agree that 1/2 is greater than 2/5? 2/4 is greater than 2/5. Okay, so function A, the slope is greater. I'm going to write this down. I'm not going to get this wrong. Slope is greater. Okay, now what are they asking us to compare? They want us to look as well at the y value when x is -10. All right, the y value when x is -10. Okay, so when x is -10, again, we want to know what is the y value when x is -10. So I'm going to go to my equation. I'm going to go y equals 1/2 of -10 plus 3. Well, that's -5 plus 3. That's -2. So the y value for function A when x is -10 is -2. Let's see if I can do this one. All right. When x is -10, right there, wow, it looks, is it at exactly -2? Well, let's see. This one has a slope of 2/5 down to 1, 2, 3, 4, 5. Say it isn't so. It is the same. When x is -10, y is -2. All right? So the slope of A is greater, but those values are the same. The slope of A is greater, and they are equal. Cross your fingers. Okay. I'm going to stop there before I make any more mistakes. But I hope you can look past that last mistake I made and understand how you can find slope and y-intercept and find output given an input on a table, on a graph, or an equation, and make those comparisons. We are diving headfirst into algebra here, guys. I hope you like it. Until next time.